Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 3 of Kubernetes Troubleshooting Zero to Hero series, and in this video we will learn 4 concepts: nodeSelector, node Affinity, Taints and Tolerations. These concepts are very important because they are used by DevOps engineers in their day-to-day life while working with Kubernetes clusters with multiple nodes. And these concepts actually help DevOps engineers in implementing things like which pods have to be deployed on which Kubernetes nodes. I mean, have to be scheduled on which Kubernetes nodes. And similarly, which Kubernetes nodes should avoid certain pods to be scheduled on them, which Kubernetes nodes should become unschedulable for all the pods, maybe during the backups or upgrades. So these concepts are very important, and if they are not implemented in the right way, they can lead to certain pods going into unschedulable state, which can create downtime for your customers. So it's going to be very interesting. We have the complete notes already available in the Day-3 folder. If you just go to the README file, you can use this as a revision material after watching this video. And you also have the manifest files, which I am going to use in the demo section. So please watch this video till the end. Let's get started with the Kubernetes cluster itself. So I have a Kubernetes cluster. If I just do kubectl get nodes, so you can see I have a multi-node Kubernetes cluster. Multi-node is important for these concepts because these concepts are related to pod scheduling. So if you have multiple nodes, it is easy to understand these concepts. And creating a multi-node cluster, if you're using Minikube or creating multiple Kubernetes clusters, is not that easy. So what usually I do when I'm going for these kind of concepts, I would prefer using things like kind or K3D. Basically, to just give you an understanding. So kind K3D is also on the similar concept where Kubernetes inside Docker. That is, if you're using things like kind, your entire Kubernetes cluster runs within a Docker container. And the advantage of this is because your Kubernetes cluster is running inside a container, they are very lightweight. So your Kubernetes cluster becomes very lightweight, and you can spin up multiple Kubernetes clusters on your machine, that is on your laptop, or you can also create Kubernetes clusters with large number of nodes. So that is, I've created Kubernetes cluster with 4 nodes. It's very simple. You can also do it. The prerequisite is you just need to have Docker running. I'm running Docker using Docker desktop. And then if you go to kind official documentation, it's very simple to install it. Whether you're on Windows, Linux, Mac OS, it supports all the flavors. If you're on Mac, you can just run brew install kind. Let's say you're on Windows, and if you have Chocolate installed, you can just run choco install kind. Let's say you don't have it, you are using a old Windows machine. You can also use this PowerShell script, just run it, and you have kind up and running on your machine. Once you have kind, you can just run this command, kind create cluster --name is equals to, let me call it as Abhi. You will see a cluster will be created. It will not even take 30 seconds, right? Let's see, ensuring node image preparing nodes, writing configuration, starting the control plane. Maybe it took 10 seconds till now. You can see the cluster will be available for you within 30 seconds of time. And you can also literally delete this cluster in like 2 seconds. That's it. You have the cluster now. If I do kind get clusters, you can see that I'm already running 2 clusters. One is the one that I've showed you initially, which is running with 4 nodes. And this is the cluster that I've just created. If I do kubectl get nodes, this is a single node cluster that I've created. So by default, kind also creates a single node cluster, but you can create a simple file like this. Okay, you can get this from the documentation, or you can also get this from our GitHub repository. If you want to increase the number of nodes, just add one more line here. Nothing more than that. You can just say role. Do you want to add a master node or a worker node? If you want to add one more master node, you can just say control plane. And if you want to add one more worker node, you can just say worker node. So this way, you can create a Kubernetes cluster with n number of nodes without any performance issues on your laptop. And deleting cluster is also very simple. Just say, oh, sorry. Now that I have a configuration file, right? I'll also show you how to create Kubernetes cluster with multiple nodes. So I'll just change the command kind create cluster -- name. Now let's call this as maybe Abhi multi -- config is equals to what is the name of the file? In our case, I think it's multi-node cluster.yaml. So just copy this again and paste it. So you will see it will not take more time. It will create a 6-node Kubernetes cluster this time because I think we have increased a master node and a worker node. If I have saved that file, if I have not saved that file, again, it will create a Kubernetes cluster with 4 nodes only. Let me quickly show you this one, because if you want to practice things like node affinity or nodeSelector or things like Taints and Tolerations, it is good if you have multi-node Kubernetes cluster. And going ahead in our troubleshooting skills, this will also help. So if possible, create kind clusters on your machine. Creating similar clusters on EKS, AKS, or GKE, it will cost you a lot. So I would prefer this option. That's why I wanted to share. Now, if I do kubectl get nodes, see, I've got a new Kubernetes cluster that is created. Okay, probably I did not save the file, but you can see the name of the cluster, Abhi multi control plane, Abhi multi worker, Abhi multi worker 2, worker 3. So I've got new Kubernetes cluster with 4 nodes. Overall, kind get clusters will show that I have 3 clusters. Perfect. Let's delete the clusters that I've created and let's go back to the tutorial with the actual cluster that I already have. So I'll just do kind delete cluster Abhi. Sorry, cluster -- name is equals to Abhi. Deleted. Let me also delete Abhi multi. And once you delete the cluster, if you do kubectl get nodes, you will see that your kubectl is still pointing to a previous cluster that you have deleted. What you can simply do is you can use this command called kubectl config view, which will show all the Kubernetes clusters that are on your that your kubeconfig is connected to. In my case, I have some sensitive information as well. So what I'll be doing is I'll just grep with kind, because I don't want to show all the clusters that I have. There is some domain specific clusters as well. So this is the one, kind multi. So simply I can do kubectl use context kind multi, and now kubectl config use context kind multi. So this command will help you to switch the context. Your kubeconfig might be pointing to multiple Kubernetes clusters. When you are working in organizations, you are, you might be expected to work with a developer environment Kubernetes cluster, staging, production, or you might be working with large number of Kubernetes clusters. Using this command, you can switch between the Kubernetes clusters. If you have one more Kubernetes cluster called kind dev, now if you run this command, your Kubernetes kubeconfig will point to this new cluster. Got it? Perfect. So now let's verify kubectl get nodes, and we can see that, okay, it is pointing back to the cluster that I've created 3 hours ago. Now let's get started with our demonstration. Till now, I've just explained how to create a multi-node Kubernetes cluster, because that will help you in the troubleshooting videos going ahead. Now I have a simple Kubernetes deployment file. Okay. What I'll do is I'll just try to deploy this Kubernetes YAML file. You can see it's a simple Nginx Kubernetes deployment. I just have one field called nodeSelector, and in the nodeSelector, I am updating something. I'll explain you what is this nodeSelector and all. But let's say within the nodeSelector field, I'll just update a key value pair called node name is worker, or node name is AMD worker or ARM worker. Okay. And now I will not change anything else in the deployment file. It's a simple Nginx Kubernetes deployment, which will work if I just do kubectl apply -f. Now that I have added a field to the spec called nodeSelector, and I've provided the node name as ARM worker. Now let's see what will happen if I do kubectl. First, let's see if there is any deployment. Let me delete it. Kubectl delete deploy Nginx deployment. Cool. Now let me run this YAML file, kubectl apply -f deploy nodeSelector.yaml. It's a random name. You can provide any name, that's okay. The expectation is that the pod should be running. Let's see what happens. Kubectl get pods. Okay, they are in the pending status. It's a simple Nginx deployment. Ideally, it should be up by now. Let's see using watch. It is 23 seconds and nothing is progressing. My pods are still in the pending status. So what should be my next step? I should be doing kubectl. Let's pick up one pod. Let's pick up this one, because there are 3 replicas of the same pod. I'll just do kubectl describe pod name to see what is the issue. Why is it still in the pending status? So for that, I'm using the describe command. So it's throwing an error which says, it's a very important one to read. Warning, failed scheduling. At the beginning of the video, I explained if you don't use nodeSelector properly, your node or any of these things that we are learning today properly, your node will go to the failed scheduling. This might happen in your organization. Let's say you joined as a DevOps engineer. You got this YAML manifest from someone. Someone has shared this with you, developer or other DevOps engineer, and started deploying it. You see that your pod is in the pending status. When you describe it, you got this error. Let's troubleshoot why. So it says failed scheduling, default scheduler, 0 out of 4 nodes are available, where one node has untolerated taint, which is again a new word for us. Let's say you don't know what is taint and toleration. So it says one node has untolerated taint. We will ignore that for a while. We will learn that in the taints and toleration concept. And it says for preemption is not helpful for scheduling. That is, there are 4 nodes. kubectl get nodes, but none of the nodes is actually available for the scheduling of this pod. Why? Because if you go back, if you do kubectl edit pod followed by the pod name, you will see that this pod or the complete deployment is using a node selector which says node name is ARM worker. So what is our first concept? The first concept is node selector, where node selector is a field in the Kubernetes pod, and this field will help the nodes, or this field will tell the kube scheduler that schedule the pod only on a particular node. And how do you identify that particular node? As a DevOps engineer, within the node, deployment.yaml file or within the pod.yaml file, you will provide a certain label. And if there is any node with that particular label, only then schedule the pod on that particular node. If there is no node, then keep my pod in the unschedulable status. You might ask, but Abhishek, why will someone have this strange requirement? So assume you have a pod, and this pod is actually running an application which will only work if it runs on ARM processor Linux machine. If you run this pod or application on a Linux machine with AMD processor, maybe it does not work, or it works with not better performance. So you want your pod to be only scheduled on a node with ARM processor. So what you will do is within your node, you will put that node selector label, which will tell the kube scheduler that only schedule on a node which has the label called something like this. Where I am using this label in your organization, you can use any label on your particular node. But you might ask me, but Abhishek, how will a node have this particular label? It's very simple. You can just go to the particular node as a DevOps engineer when you have 4 nodes, let's say. Okay. And when you know that you have a requirement that certain pods will only be scheduled on the ARM processor, you have to create a Kubernetes cluster where one of the node or 2 of the nodes, 3 of the nodes, depending upon your requirement, will have ARM processor running. And what you will do is you will go to certain nodes, kubectl edit node. Let's say this node is running with ARM processor. So you will say kubectl edit node followed by the node name. You will go to the label section and you will simply add node name ARM and save this file. I have to do it again because I did a typo. You can also use the command called kubectl label node, but I wanted to show it real time. How does that happen? That's why I'm editing using the kubectl edit command. Node name ARM. Now, if you just go to the node again, kubectl edit node multi worker. You can do it using kubectl commands also, but I am intentionally using the kubectl edit command instead of using commands like kubectl edit or kubectl get node with filter label. So this particular field is added. Perfect. Now let's see if the pod is scheduled or not. Kubectl get pods. Okay, they're still in the pending status. Let's see if I have added the right label. Kubectl edit pod followed by one of the pod name. What does it say? The node selector says node name arm worker. So I haven't edited the node in the right way. I'll just say arm hyphen worker. Save it again. And now if we do kubectl get pods and watch it, the pods are in the running status. So you understood what is node selector. You understood how to identify the issue, how to troubleshoot it, and how to fix it. Just a very quick recap. What is a node selector? So as the name suggests, node selector basically helps DevOps engineers or the Kubernetes administrators implement how a particular node can be executed on a specific node. So the requirements can be you have a pod in your organization or you have an application on your organization. Maybe that will only work if it is run on a Windows node. Or maybe it will only work if it runs on a node with ARM processor or a node with AMD processor. So when you have such requirements, you will do two things. Step one is you will go to the node and you will add a particular label on the node. Once you get this kind of requirements from your developers, step two is once you add that label to the node, you will go to the particular pod and you will add something called as node selector, right? So you will add this field called node selector within the pod. And if this is not done in the proper way, as I've shown you initially, your pod will go to the unschedulable status, that is in the pending status. You can use kubectl describe, identify the issue, then fix it. You will see your pods will move to the running status immediately. So this is our concept one for today, which is node selector. Very simple, helps scheduler understand which pod has to schedule on which node. If you don't have node scheduler, Kubernetes scheduler will take its own decision by using its scheduling algorithm. Okay, Abhishek, we understood what is node selector. Now, what is node affinity? So the difference between node selector and node affinity is that with node selector, you are forcing the scheduler that schedule the pod only if you find the right node. That is, it's a hard match. If you don't find a ARM processor node, in our previous example, what is node selector telling the scheduler? Do not even schedule the pod. Whereas node affinity is a feature, it has two options. One is preferred and second is required. Required works almost similar to the node selector, where you are telling the scheduler that only schedule if I find the 100% exact match or the exact required node. Whereas with the preferred scheduling option, what you are telling the scheduler is that, okay, first try to find the exact same node where I will provide you the label. If you find the label, just use that particular node. If you don't find, then I am okay. You can schedule it anywhere. This is the difference between Affinity and Selector. With nodeSelector, you are doing a hard restriction, only schedule if you find the right match. Whereas with Affinity, you are providing more flexibility to the scheduler if you are using the preferred option, where you will tell it, okay, if you find, schedule on it. If you don't find, still I'm okay. You can schedule it anywhere. Let's try to see this practically. So I have the same deployment, but what I have changed is, first thing, I have changed the replica to 1 because this is preferred scheduling example. I don't want you to confuse more. If I provide multiple replicas, you might see schedulers scheduling few replicas on the preferred node, few replicas on a different node. You might get confused. So I'll keep the replica count to 1. And here you see that I have added the Affinity related configuration. If you ask me that, Abhishek, should I remember this configuration? Not at all required. This configuration is a standard configuration. If you are going with preferred scheduling, you will use the same configuration. Probably you can add more number of labels, but this will always remain the same. So there is no point of remembering the syntax. You just need to know what is the concept of Affinity and what are the different options. So here I'm using preferred during scheduling, ignore during the execution, which I have explained. There is another option which is required during scheduling, which we will cover in a while. Now, this is the preferred scheduling option where I said prefer a node which has foobar, or let's just change it and say prefer a node which has label key as node name or node architecture, where the architecture is Windows. So the key of the label is node architecture and the label is Windows. Of course, I don't have any node like that. So now let's see, will it keep my pods in the unschedulable status as the node label selector feature which we have tried, or will it randomly schedule on any node? Let's try that. So kubectl apply -f deployment preferred scheduling.yaml, kubectl get pods. So the pod is in the running status. And if I do -o wide, you will see that it randomly got scheduled on any of the node that is available because you set the preferred option. If I just change it, right? Let me delete this. And if I go back to the preferred, and if I use the label which exists on my node, which we have created previously, node name, I hope I remember it correct, ARM worker. Now let's try to apply -f deploy preferred sched.yaml. And you will see this time it got scheduled on multi-worker. And if you do kubectl edit node multi-worker, you will see it has that configuration called node name ARM worker. Previously, it got scheduled on multi-worker 3, which is the third worker node. And now it got scheduled on the worker node, which has that node configuration. Why? Because kube scheduler found a node which is preferred configuration of mine, and it said, okay, the worker node is available with your preferred configuration. So let me go and schedule on that. So this is the example of preferred scheduling. And if you just change it to the other example that I have here, required node affinity feature, where everything is same, you will just say required during scheduling. And what will happen with that is it will work exactly same as the node selector feature. Of course, there is some difference internally, but for now, you can just assume that it works similar to the node selector. So overall, if someone asks you in the interview, what is the difference between node selector and node affinity, you can tell them, although the feature are little similar, node affinity grants more granular level of configuration or more flexibility for the DevOps engineers, which says the kube scheduler, you can go with the preferred configuration. And if you don't find the preferred configuration, you can schedule it anywhere. Perfect. So this is about node selector and node affinity. Perfect. We learned about node selector, node affinity. Now, what exactly is a taint? Let's say you have a Kubernetes node and you don't want to schedule anything on this particular node. Till now, with node selector and node affinity, we were only talking from the pod point of view, where we were thinking, what if a pod wants to be scheduled on a particular node? Now, what if a node should be completely unschedulable? That is, any pod should not be scheduled on this particular node. You might ask me, but Abhishek, what is the requirement for it? Why you have a node which is unschedulable? The best example is upgrades. So if you have a Kubernetes cluster running with a particular version, let's say the Kubernetes cluster has 3 worker nodes, and you want to upgrade the Kubernetes cluster. Assume this is a production Kubernetes cluster, and you want to upgrade this to a new version 1.29. Okay, to upgrade the cluster to a new version, upgrade the worker nodes to a new version. This is a production cluster. You cannot upgrade all of them at once. So what you usually do is you drain a particular node where you will move all the pods that are running on the particular node to a different node. Once all the pods are evicted, once they move to a different node, then you make the node unschedulable. Once the node is made unschedulable, now this node is idle. Kube scheduler is not going to schedule anything on this particular node. So you can bring this node down, you can upgrade it, and then you can remove the unschedulable status, and the new version is up and running. So there are multiple ways of doing Kubernetes upgrades. This is one way that I'm talking about. And in this way, you will make your Kubernetes node unschedulable. So the upgrades is the best use case. How do I do that? So the concept that you will use is called as taint. So taint is, again, you can just consider it as a label or any particular stamp that you are applying to a particular node, which explains the kube scheduler that my node has to be unschedulable. Okay. So how do you do that? It's very, very simple and straightforward. The documentation is also very straightforward because there are not many capabilities with the taint. You can either make your node unschedulable, not schedulable, or you can move it to no execute status, or just like node affinity, you can also do prefer no schedule. Okay. What are the 3 different types of taints which are more popular? No schedule is one that you can do, where your node will go to complete not schedulable status. You can do no execute. No execute is little bit dangerous because when you do no execute, all the pods that are on your particular node will immediately stop working. So no execute. And then there is preferred no schedule. Abhishek, when will I use preferred no schedule? You said no schedule is used for backups or upgrades. But when will I go with preferred no schedule? Best example is assume that you have a node and the performance of the node is declining. The node is going through some CPU issues, memory issues, or there is some issue with the node that you are still identifying. The node is not behaving the expected way. There is some performance issue, which is the best use case. So in these cases of performance issues, maybe you want to say preferred no schedule. Rather than saying completely not scheduling on it, you can say in the worst case, schedule the pod on this particular node. Otherwise, go with the other nodes that are available. Now, how do you taint? So you can just use this command called kubectl taint node no schedule. So if you look at the command, no schedule is the effect that you are applying or the taint that you are applying on the node 1, which I have to change to one of my node names. And key value pair will come into picture when we talk about tolerations. So what are my node names? kubectl get nodes. Let me pick up one of my node called worker, and let's say kubectl taint nodes multi-worker. Let's say key1 is equals to value1 colon what is the effect. We will talk about this key value pair in couple of minutes when we talk about tolerations. So now I'm making this particular node as no schedule or unschedulable. If you go to your Kubernetes control plane or the master nodes, just do kubectl edit node. So you will see this particular node already has a taint which is called as no schedule. Why does this already have a taint as no schedule? Because we usually don't schedule the pods on the control plane. That's why all your pods that you are trying to schedule go to the worker nodes. So out of the 4 nodes, control plane is already tainted as no schedule. Worker I've just scheduled tainted as no schedule. Let me repeat that for worker 2 as well. Okay. Now all these 3 nodes are tainted as no schedule. We are just left with one node. Let's see my default action. Will it go to this particular node or not? It should only be scheduled on this particular node because there is no other option. So apply -f. We can do a simple deployment also where I'll just remove the node selector so that you are not confused. Now this is a plain deployment. kubectl apply -f. Let's try this out. Okay. And if we just do kubectl get pods, so if we do -o wide, you will see it got scheduled on worker 3. Why? Because that's the only option that is left. If I taint worker 3 also, you will see the pod has no way it cannot get scheduled, right? So this is the advantage of using taints. By using taint, you can decide what is the behavior of the node. During the upgrades, you can taint a particular node as unscheduled so that your node can go to the unscheduled status. You can take that node and perform upgrades. If you have any performance issues with your node, you can take preferred no schedule taint on that particular node where it will be scheduled, but in the worst case. If you schedule a taint, if you taint a particular node as preferred no schedule, you might still see some pods running on that particular node, but that is because all your other nodes are busy and there is no other option for your scheduler. Okay, the final concept, tolerations. So tolerations is very simple to understand. As the name suggests, tolerations is basically an exception that is given to certain pods. For example, in our case, we have 3 nodes in the no schedule status, right? We have tainted the 3 nodes as no schedule, but for some reason, you still want certain high priority pods. Okay, in your organization, you have some high priority pods which are performance critical or production critical. They should definitely run. So what you can do is, to these pods, you can add a toleration or an exception with which they can still run on the no schedule or any tainted node. Okay, no schedule is just an example. You might have no execute or preferred no schedule. On any of these taints, you can still run the pods if you have tolerations set on that particular pod. Like I have told you, when I was tainting the node, I told you that we are using this key value pair for the tolerations part. So this is where tolerations come into picture. The no schedule is an effect on the node, but if you still add a toleration to the pods which are matching this key value pair of your effect, right? The effect is no schedule, and the reason why we provide key value pair for this particular effect is for the scheduler to understand if there is a pod that has the tolerations that are matching this key value pair, then you can still schedule the pod on this particular no schedule node. So the syntax for the toleration is, we can look at the documentation. You will just add this particular field inside your pod. In our case, we will go to one of our pod. Let's go to the same one. Deployment. So here, so I have added the toleration where key is key1, value is value1. You can add this key value pair. I'm repeating it again and again. You can put any values in this key value according to your organization standards. And now if I just delete the deploy, right? Where is the deploy currently running? kubectl get pods -o wide. You can see it is running on the worker 3, which is the only available thing. Let me also taint this one. So everything is unschedulable now. All the nodes are unschedulable. Now let's delete the deployment and let's create it one more time. kubectl apply -f deploy. So ideally, all the nodes are of no schedule, so nothing is available. If you don't add any tolerations, your pod should not be scheduled. But let's see if it works now. Still running, and where is it running? One copy is running on worker 3, one copy is running on worker, one copy is running on worker 2. So I've used the replica as 3, and still you can see all the pods are in the running status because you have tolerated the pods. Even though the nodes are in the no schedule status, because you added this toleration, So this toleration is basically helping you schedule your pod. And if you remove this, your pod will be unschedulable, which we have seen already. So this is the concept. I'll highly recommend you to practice each and everything that I have explained, because sometimes this might look simple, but trying it on your production critical or trying it on your actual Kubernetes clusters might sound tricky. So better create Kubernetes cluster, create this environment, do the troubleshooting that I've done, and try to implement things. Thank you so much for watching the video. I hope you found it useful. Troubleshooting videos take a lot of time, but still I'm doing it because I feel you will also do the things from your side and explore Kubernetes. See you all in the next video. Take care. Bye bye.